Okay, so I'm talking about section 2, which explains the covalent bond. And for sure, you know that covalent bond is the bond formed by sharing the electrons. Why electron shares? Every atom has a dream. The dream of each atom is to reach the octet configuration or the configuration of the nearest noble gas, because this configuration gives the atom the stability. To do this, the atom loses or gains or share electron. The shared electron or the covalent bond takes place between two nonmetals. Let me give you examples, types of covalent bond. There are two ways to classify the covalent bond. The first type to classify is to divide them into either single covalent, like the bond between, for example, hydrogen and the chlorine. The hydrogen has atomic number of 1. So it has 1 electron in the outermost energy level. So hydrogen needs 1 more electron to be 2 electrons in the first energy level. So the first energy level is stable and it has the same configuration as helium, so it is most stable atom. Chlorine, 17. So it is configured 2, 8, 7. And since there are 7 electrons in the outermost, this means that the atom tended to gain electron. Yes, right, you are. To be 2, 8, 8. 8 electrons in the outermost energy level makes the atom most stable. So both of them needs electron. None of them will give. The bond cannot be ionic. So what will happen? Okay, this is the electron of the hydrogen. This is called Lewis structure when you draw the electrons in the outermost energy levels as dots, or electron dot notation. And this is the chlorine. How many electrons? I will draw only I'll indicate the electrons only in the outermost. They are 7. So 1, 2, 3, 4, 5, 6, 7. Okay, pay attention. This pair of electron, okay, is called a lone pair because it is belonging to same atom. Also this pair of electron, are called lone pair. This is single electron here and this is single electron here, so they share together. This is the covalent bond. So this is single bond because there is only 1 pair of electrons shared between the two atoms. So now hydrogen is surrounded by 2 electrons like helium, and the chlorine is surrounded by 8 electrons like argon. This is single bond. Okay, when I say double bond, double covalent, like in O2. So this is the oxygen, the atomic number is 8, so it is configured 2, 6. So it needs 2 electrons to reach the octet configuration. So if you have 2 oxygen atoms bonded together to form O2 compound, this is HCl, this is O2. Okay, so how many electrons in the outermost? 6. So let us draw Lewis structure. 1, 2, 3, 4. Okay, 5, 6. 1, 2, 3, 4, 5, 6. And this is a lone pair. This is a lone pair. Okay, this is a lone pair type. Now these electrons will pair together like this. This is 1 covalent bond. This is 1 covalent bond, and this is another covalent bond. So see, now there are 2 pairs of electrons shared, 2 covalent bond between the 2 atoms. So this is called double covalent. The last one is triple covalent bond. Like in N2, okay, nitrogen, electronic configuration, doctors explain everything. The electronic configuration of the nitrogen is 2, 5 because the atomic number is 7, so it is configured 2, 5, right? So it needs 3 electrons to reach the octet configuration or the atom to be stable. So if you have 2 nitrogen atoms together, let us draw Lewis structure means only the electrons in the outermost, which are 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now each atom needs, yes, 3 more electrons, so this is why they will share by 3 covalent bond. There are 3 pairs of electrons between the 2 atoms. This is called triple bond. And pay attention, if I give you, for example, okay. So pay attention that if I give you ammonia, okay, where nitrogen combines with the 3 hydrogen, this is the nitrogen, and these are the 3 points because nitrogen is the 7, 2, 5, so it has 5 electrons in the outermost, and it makes a 3 covalent bond with the hydrogen like this. See? So this is not a triple bond, this is a 3 single bond. So don't confuse. The triple bond means that the 3 pairs of electrons should be between the same 2 atoms. But here, these are different hydrogen atoms, so these are a 3 single, not 1 triple, okay? If I give you, for example, C2H4 type, this is carbon and carbon, carbon 6 configurated 2,4, so it has 4 electrons in the outermost, okay? So 2 of them like this. So it makes 2 hydrogen, 2 covalent bond like this with the carbon, and 1 with the hydrogen, another 1 with the hydrogen. Same story here, like this. So here we have 4 single bonds and 1 double bond. Okay. Another type to classify covalent bond is according to the polarity. So covalent bond can be nonpolar if the difference in electronegativity, you remember what is electronegativity? The tendency of electrons to, the tendency of the atom to attract the electron in bond. For example, if you have hydrogen and the chlorine, 1, 2, 3, 4, 5, 6, 7, and 1, this is covalent bond, and the electrons is known to be shared between the 2 atoms. But chlorine has more tendency to attract the electrons, so this is why it acquires a partial negative charge, and the hydrogen acquire a partial positive charge. So here I say that the bond is polar covalent. So if the difference in electronegativity ranges from 0 to 0.3, so this means that it is nonpolar. 0, like when in the element, when the 2 atoms are the same, like in Cl2, O2, H2, okay, N2, like this. So if you have hydrogen, okay, because the 2 atoms are the same, so the tendency of each atom to attract the electron is the same. So this is why the electrons are evenly distributed between the 2 atoms, so they are not attracted toward one more than the other. So this is why it is nonpolar covalent. But if there is difference in electronegativity ranges from 0.3 to 1.7, it will be polar, because this means that one atom will be more electronegative than the other. To an extent, it can attract the electrons toward it a little bit. Like, so the condition here, the difference in electronegativity is greater than 0.3 and less than 1.7. Okay, the example is, for example, CO2. Oxygen is more electronegative than carbon. In the exam, you will have the table of electronegativity, and you will count the electronegativity of carbon and oxygen, and then you subtract. if the subtraction result is less than 0.3, so it is nonpolar. If it is more than 0.3 but less than 1.7, so it is polar. If it is more than 1.7, so it is ionic. Because if the difference in electronegativity is more than 1.7, means that the more electronegative atom has very great tendency for the electron to the extent it can, take the electrons out of the other atom. Okay, so this is polar covalent, and if difference in electronegativity is greater than 1.7, this means that the bond is ionic. We said before that the atoms gained or lost or share electron to reach the octet configuration. But there will be some exceptions. Like when I say, pay attention, because you may find this, you will actually find this in the exams, the exception. So understand. If I give you something like boron trifluoride, this is a compound, how it is formed. Again, electron configuration will help a lot. Boron is 5, so it is configured 2-3. So it has 3 electrons in the outermost. And the fluorine is 9. Okay, so it is configured 2-7 with 7 electrons in the outermost. So when they make covalent bond, the boron will be central atom. And the Lewis structure, I said we draw only the outermost electrons. They are 3. And then this is the 3 fluorine atom. 1, 2, 3, 4, 5, 6. What we call this pair? Yes, lone pair, right? And this is single. 1, 2, 3, 4, 5, 6, 7. And these are the covalent bonds. See? Okay. So now each fluorine atom is surrounded with 8 electrons. This is okay, but if you count the number of electrons around the boron, they are 1, 2, 3, their own, and the other 3 came from the covalent bond. So boron now is surrounded by 6 electrons. So it didn't reach the octet configuration. So this is an exception. When I give you this example, beryllium difluoride, so beryllium is 4, so configured 2-2. It has 2 electrons in the outermost, and fluorine, we just draw it. So this is a beryllium with 2 electrons in the outermost. This is the Lewis structure. And this is the fluorine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and these are the covalent bond. So now fluorine is, yes, it reached the octet configuration, but how many electrons around the beryllium? It's only 4. So the beryllium in beryllium difluoride, boron and boron trifluoride have less electrons than the 8. So they are exception from the octet rule. It also can be more, like phosphorus pentachloride type. There is a molecule called the phosphorus pentachloride. Phosphorus is 15, so it is configured. You help me 2, 8, 5. It has 5 electrons. So this is the Lewis structure. Boron pentachloride. Okay. So 1, 2, 3, 4, 5. These are the 5 electrons in the outermost. And the chlorine is 17. Configured 287, so it has 7 electrons in the outermost. So this is the chlorine. Okay, there are 7 electrons in the outermost. 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7, 2, 4, 6, 7, and these are the bonds. Okay, so now each chlorine is surrounded with 8 electrons. Its own 7, and the one came from the phosphorus. But how many electrons around the phosphorus now? There are 10. Its own 5, and the 5 came from the covalent bond. So this is also a deviation or exception of the octet rule. I can give you the last example. sulfur hexachloride, sulfur Cl4, Cl6, I'm sorry. Okay, so sulfur is 16, 2, 8, 6. Okay, and this is the Lewis structure. 1, 2, 3, 4, 5, 6. And these are the chlorine, the 6 chlorine atom around. Okay, each share with 1 electron, and these are the rest of the lone pairs, like this. Okay, so now chlorine obeys the octet rule. It is surrounded with 8 electrons, but sulfur is surrounded with a 12 electron, its own 6, and the 6 came from the 6 chlorine. So this is also a deviation or exception of the octet rule by more than 8 electrons. Okay. Now the resonance. What is the meaning of resonance? Resonance means the molecules or ions that can't correctly represented by single Lewis structure. The most famous example for resonance, like O3, we can understand it by example. So if I say that these are, it contains 3 oxygen atoms, each oxygen atom has 6 electrons. So how the 3 atoms combine together? We know that in oxygen O2, there are double covalent bond between the molecule, and it is okay and stable, and each atom surrounded with 8 electrons. But if they are O3, so if I make something like this, this is the first one, and this is the second one, and this is the third. Okay, and I make the 2 bonds here and 1 bond here. Okay, what is unusual? This is the oxygen atom surrounded with 6 electrons, its own. This is the correct Lewis structure for the oxygen atom, and it makes a covalent bond with 2 electrons from the neighboring one. It's okay. Let us count the number of electrons in the on the oxygen atom in the middle. 1, 2, 3, 4, 5. This is not normal. Let us count the number of electrons in the outermost of the third one. 1, 2, 3, 4, 5, 6, 7. This is also not normal. And this means that there is an electron shifted or switched from the middle oxygen atom to the third one, such that they can combine. Okay, so this is a way that can explain how 3 oxygen atoms combine together. And because this is unusual, so this is why this structure is not stable. The electrons can rearrange again such that they can, it can be like this. Okay. So this is here 7, يعني here the first atom in the above molecule was surrounded with 6 electrons. It's okay. Second and the third, something unusual here. 1 is surrounded with 5 and 1 is surrounded with 7. Now they will exchange. They will adjust the electron arrangement between 2 and the 3, and the 1 يعني can slightly change to this way. Like this. So now the first one is surrounded with 7 electrons, the third one is surrounded with 5 electrons, and the third one now is surrounded with 6 electrons. It's okay. So you can get what happened. The electrons rearrange themselves such that we don't have an atom which surrounded with 6 electrons, the correct number forever, and the one surrounded with 5 or 7 incorrect number forever. So they started to switch the electrons between here and there. This is called resonance. Also, there is another example, SO3. Okay, how sulfur can react with 3 oxygen atoms So sulfur has 6 electrons in the outermost, so it can make it like this. We can make it like this. Okay. And this is the electron. Now here, notice that the electrons here are surrounded with 7 electrons. This is unusual. Here the electron is surrounded with 7 electrons. This is unusual, okay? And this oxygen above is surrounded with 1, 2, 3, 4, 5, 6. This is the normal. So the bond will be like this. Okay, so the number of electrons on the 4 atoms, they are the same. 6 electrons from the sulfur, 6 from oxygen, 6 from oxygen, 6 from oxygen. But they rearrange around the 4 atoms such that we can make bonds between sulfur and the 3 electrons. Also, they can switch to the other 2 forms of resonance. The electrons will start to rearrange in other 2 forms or in other 2 ways to give the 2 other resonance structure. Okay? In this section also, you need just to know what is the definition of chemical bond, ionic bonding, covalent, nonpolar, and polar. These definitions, you will find them in the book. And if we will ask you about them, we will not ask you to define. They may come in form of multiple choice or scientific term or something like this. Just let me draw the other 2 resonance structures of the sulfur trioxide, and we will be over with this. So I drew one in the last slide, the other 2. 2, 3, 1, 2, 3, 4, 5, 6, 7. Notice that this is unusual. 1, 2, 3, 4, 5, 6, 7. Notice that this is unusual. 1, 2, 3, 4, 5, 6. This is usual. Okay. A third resonance form. 1, 2, 3, 4, 5, 6, 7. Unusual. 1, 2, 3, 4, 5, 6. This is usual. 1, 2, 3, 4, 5, 6, 7. This is unusual. So again, the electrons and they exchange. So the electrons exchange the arrangement around the 4 atoms such that they can keep the bonds between the sulfur and the... So simply, resonance means that the total number of electrons in the outermost energy level of all atoms in the molecule will start to rearrange themselves in different way such that they exchange their position on the atom to make them sometimes with usual arrangement, sometimes with unusual arrangement. Formation of covalent bond. If we take a relation, I'm so sorry, this is so bad. If we take a relation between the distance between the 2 molecules and the potential energy, okay, we will have something like this. Okay, and this graph is important actually. If these are the 2 atoms that will covalently bond, this is the potential energy. Notice that for these 2 atoms to combine to make the covalent bond, the potential energy must decrease. Okay, and when it reaches its lowest potential energy, at that time the combination can take place and the bond is formed. Okay. So again, the atoms, when they combine covalently, they are at their lowest potential energy, lowest energy level, okay? The bond length for sure is the distance between the two atoms covalently bonded, and it is measured when they started to bond, means when they are at the minimum level of potential energy. Okay. So if they are bonded, this means that this bond has energy, and for sure the energy is inversely proportional with the distance. The greater the energy of the bond, the more the atoms are attracted, and the less the bond length or the distance between the two atoms, okay? So the bond energy is the energy required to break the chemical bond. By how much energy they are bonded means by how much energy you need to give to overcome this attraction. يعني if they need to lower the potential energy by X such that they combine, so this means that you need to give this X such that they separate, right? Okay. So again, the definition of molecule, molecular compound, chemical formula, diatomic molecule, bond length, bond energy, octet rule, definition of bond, covalent bond, nonpolar and polar, and all the definitions that you will find them highlighted in the chapter. Please understand their meanings without memorization. Thank you so much.